Anybody here have a robot that does any of the phases? Cool, okay, let's start with phase 1. Does anybody have a robot that can do phase 1, which is go from one end to the other of the table, and also want to display it for everybody? Raise your hands again. You are close. Come on up. Mark.
So, had this bot here, I think 2 months ago.
You want to use this?
I'm going to probably talk loud because I have to move stuff around. I've added a bunch of subsystems to this. This is called DroidBot.
Where's the top hat and the mustache?
Yeah, we had a little bit of a show last month which had nothing to do with this. It was a little bot that was on a tight wire and I made it look like a circus. But this may not be able to do this challenge, but it's got a whole host of fun little subsystems that if people want to check it out later, feel free to come up. The one that I've mentioned on the list is a time-of-flight little radar in the front that scans around to 11 different points, and then it shows up here on the display, but also it's on a little board that talks to the ROS node that talks to the board and picks up where are all the radars and where are all these edge sensors and so forth, and publishes them on ROS topics, which are like message queues, basically, things like that. So altogether, it makes a nice little subsystem, which also has a motor controller on it. And so people want to see that, they can see it later. Now, the bot itself is running ROS right now, ROS Kinetic, and that's what most of the people running ROS right now are doing. And it's important to turn on the motor controller power. Just wanted to throw that by you there. You know, there's all these details you got to be concerned about. So we're going to start this up. This may not be able to do the particular challenge here because it wasn't meant to. I cobbled something together because we are having the challenge. But my big excitement is it's also a Raspberry Pi 3B+, and it has all that running now and all that other stuff I mentioned. So it's pretty cool. We'll just see how it does here. We have to get twist going here, and so that I can tell it to start moving forward. So now ROS is running right now on the robot, and so I don't have this scripted right now, so I have to type it, and I'll try not to type it wrong.
No
because the
pressure
command
here.
stack is not remembering what I typed at home about an hour and a half ago.
That's what copy and paste is for.
Yeah.
That's what up arrow is for.
Oh no, I actually tried up arrow, and unfortunately it's not coming up with it. So anyway, on top is the LiDAR, which a lot of people run, and this is actually running in ROS now. So if we had the visualization software and all that, we would be able to see that it is taking 360 points all around the robot and showing how far the distances are as well. So for one of the later phases when it has to find things and move them off and so forth, I'll be using that. But for now, I just have to make sure I don't make this thing go too fast, because these sensors are just barely out in front of the wheels and the wires are a little short. So if I made it go too fast, it would be unfortunate when it got to the end of the table. So as it stands now, it's got odometry running on the wheels. The wheel encoders are being picked up, and it's trying to keep it in a really nice straight line. I'm going to get over here so that in case it does, because it makes it like to within a half an inch of the table.
on now.
So. And then, see, and that's okay. But the hard part is one of these wheels slips when it turns. So this will be the trick, is whether or not it's going to make a full turn.
Nice.
Oh, I got too much turn. So actually, it's in demo mode, so it's actually never going to make it to the other side of the table. I should have put it in. It's going to like doing turn and, oh, if it gets to this side, it'll be technically across the table, won't it?
Nice. Nice.
So anyway, come by later and you can take a look at all the cool little things, OLED display, and all that fun stuff on it. And that's it for now, so thank you.
He's gonna make it.
No, it might make it.
Pretty bot.
Oh, actually, did I just hit Control C? No.
Wait a second. Is it gonna?
Kitchen.
We almost made it to what we call phase 4. Phase 4 is it falls off the table, hits the ground, and if it still runs, it passes phase 4. Also, I have an Android app that talks to my controller, and I can control it from here with tilting and buttons and all that. But I showed that a month ago, so I wasn't going to bog down this demo with that. So.
Very cool.
Hello, my name's Evan Alexeyev. So, I've been tinkering with this robot I made completely from scratch for some time now. I originally made it with a Raspberry Pi 2, and it was for obstacle avoidance. But when I heard that the Tabletop challenge was available, I decided to modify it, so I did. It's running bare bones version of Linux, Raspbian. It's just a terminal, and it does work on the Tabletop challenge.
I can take the
Okay, it started earlier than it needed to. Okay.
Run!
Oh, nice!
Do it again.
I actually did test it out on a few tables, and it worked every time. So
Don't press your luck.
This is a demo. It's not like reality. Or maybe it is reality.
It's a little too real.
for fun, earlier, while it was an obstacle avoidance robot, I actually added a BME280 environmental sensor, and it actually perfected the speed of sound that was in the area, so that these would be more accurate, even though I didn't really need it. Just for fun I did it, so that's pretty much it.
Nice.
Hi, my name is Mark Rose. I'm from Robot Garden in Livermore, and several of us in Robot Garden build robots that are similar to this. They're all round, about 8 inches in diameter, with the same set of motors. They're all Raspberry Pi based with an Arduino daughter board that controls the motors and sensors, and then I've added a Raspberry Pi camera. So this particular robot was shown at RoboGames for their tabletop there, and I took third. And I had used these fiducial markers on both the block and the goal to determine where it was, and where the block and the goal was. And then the thing that I didn't get done for RoboGames was any sort of detection of the edges of the table. So I had to make sure to put the block not too far, too close to the table edge, otherwise it would just blindly follow the block and fall off. So since then, so at RoboGames I did level 1 and level 3, since I couldn't just push the block off the table because I don't know where the edge was. So since then I've been working with the camera a little bit more to do mapping of the table, and what I'd like to show tonight is I'm using some OpenCV routines to detect the edges of the table and convert that into a simulated LiDAR message. So if you're familiar with ROS, it's a laser scan message. So I take various points in the image, and based on the edges that are found, use parallax both in the vertical direction and the horizontal direction to determine the distance, and then convert selected points at equally spaced angles into a laser scan message and send that off. So this does actually less than I did at RoboGames, because what it's going to do tonight is just do level 1. If all works well, I did test it beforehand on this particular table. If all works well, it will just drive across the table and square itself up. then turn 90 degrees, drive to one end, turn around, and drive to the other end and stop. So we'll see if that actually, if it actually is able to do that. Okay. Sorry, it's not detecting the button. There we go. Okay, so it does appear to see the edge. It's squaring itself up, turning 90 degrees. It's using the odometry for that. And now it's going to drive to the other end. And again, once it gets near enough so that it can detect the angle of the edge, it will turn slightly to square itself up. Then it moves a little farther to show that I know where the edge is. And now it's going to turn around 180 degrees. Then just using wheel odometry to do that. Now it's going to drive to the other end and hopefully square itself up and stop. I'm doing it very slowly because of the fact that I was going to do all of the image processing on the Raspberry Pi, and as you probably know, it's not a very good image processing chip. So I can do fewer than one frame, fewer than the 10 frames per second that I'm actually pulling off the camera. Well, that's all it does. So.
This is Bile. He's the first of the Digesticons, one of the Transformers, the Autobots, the Decepticons. He's one of the Digesticons. Anyway, he's going to do level 1, and that's it for now, hopefully. Okay, here we go. Victory dance. Is that loud?
Nice.
There you go.
I didn't see. Did he do it?
Yeah.
Do it again.
All right. Cool. Okay. Who? Someone over here want to go up next? No? Yeah. Camp? Do you want to do it?
I'm working on it.
My tire came off.
Okay, so
Real life, everybody. Demos. Oh, yeah. Here you go.
it's me again. So that's a little Raspberry Pi based robot, mostly Lego. I'm trying just to interface Lego Mindstorms or power function motors to different computers and stuff like that. So just to see how far you can push that. And that's now, it started out with a Raspberry Pi 2. Now it has a Raspberry Pi 3 in there. And I'm still debating if I want to convert that to ROS. But so far it's just running essentially C code to almost Arduino-based interface board to the Mindstorms, motors and sensors. So let's see if it can still do this one. So right now it's basically calibrating the IR sensors. Caught it in the corner.
I mean, technically you got from one end to the other like that every day.
No, eventually it will simply start doing random moves to get out of the corner, but
Like a Roomba?